Hello everyone, the problem that we're looking at today is classic silver difficulty and classic silver algorithm. We're looking at the same concept as yesterday, and this time's problem 2, cow frisbee. Basically, you're trying to find the number of pairs of cows that can throw frisbee with each other, and those cows, that can only happen if all the cows in the middle of these two cows have height of less than the minimum of these two cows. Yep. So, and also you can have at most 3 times 10 to the 5th. So you can pause the video first and see if you can solve it yourself. I would say quite standard silver algorithms. Not the easiest, but definitely not overly difficult like the problem yesterday. So, okay, basically how I imagined this was reverse psychology. Instead of trying to find every single pair that I can throw, which is obviously at least n squared, I try to find the number of pairs that can't throw. And there's a really easy way to find this because we can, like, once again, kind of reverse psychology. And instead of thinking about this pair, we think about what makes them unthrowable. Like, which cow in the middle blocks a certain pair. So basically, I tried to find, for every single eye, I tried to find how many pairs it block. And of course, there could be cases where multiple cows block. Then in that case, I just give it to the highest one, I believe. It's either the highest one or the leftmost one. I can't quite remember which one this implementation does. So obviously, on left and right, you will want to find the first cow that's greater than this current cow, and that is the cow that blocks this current cow from throwing with other cows beyond this cow. So I use 2 monotone stack, which is the standard algorithm for finding the closest before or after with value of greater than or maybe less than the current one. In this case, it's greater than that we're trying to find. So Li is the first one before I that's greater than I, and Ri is the first one after I that's greater than I. So this middle part is just finding, for every single I, the number of pairs that cannot be thrown. And sum is the sum of all number of pairs that cannot be thrown. Obviously, answer is the total number of pairs, and answer minus sum is just the number of pairs that can be thrown. So you can pause it for a second and check out this middle part, which is the most important of this whole code, in which we find how many cows are blocked from being thrown with I. So obviously, we can see I minus Li, that's the number of cows that I can definitely throw to. Ri minus I is also the number of cows that I can definitely throw to, because obviously between Li and Ri are all the cows that are less than or equal to I, so I can throw with them. And let's see, left I equals the summation from 1 to left I, because we want to find, because every single cow left of I can also throw with every single cow right of I. Right, so we have that. These two are basically doing the same thing. We update the left with the summation of 1 to left, and R stays the same, and then we get left back to what it was and sum the R instead, and then we multiply those. So it's basically every single cow throwing with every single other cow on the other side of I. And then if ARI, I don't quite recall what this line is for, because I believe if the definition of RI is ARI being greater than AI, but if this is true, then the total number of pairs is decreased by Ri minus Li plus 1, which is the number of cows that's enclosed within these two very tall cows, Li and Ri. And sum, which is the number of pairs that doesn't work, is incremented by Tm that we found this time. So yeah, this problem, quite easy, quite standard. It's just some details I can't recall, but I believe it shouldn't be that difficult. So hopefully after this video you understood, and I'm not even going to record a separate part for the grind report because it didn't grind at all. There was a Yo-Yo Ma concert today, and I went watching that, and I also did some speech stuff and just didn't have time to do anything other than record this video. Thanks for watching. See you tomorrow.